Section 12.2 is on surface areas of prisms and cylinders. A prism is a polyhedron, and a polyhedron is a three-dimensional shape that has two parallel congruent faces that are called the bases. The faces that are not the bases are called lateral faces, and they intersect at lateral edges. And the distance between the bases is called the height. Let's take a look at an example of one. Here's a hexagonal prism. Okay, it has a hexagon on the top and a hexagon on the bottom. Those are the bases because they are parallel and congruent to each other. The lateral faces are the other faces that connect the two hexagons, and those are shaped as rectangles. The height is represented by this blue dashed line in the middle, and that's the distance between the bases. And the lateral edges are these edges right here, where the lateral faces meet each other. The lateral area of a prism is the sum of all of the areas of the lateral faces. And the surface area is the lateral area plus the area of the bases. So in this case, the lateral area is just the area kind of around the outside. The surface area is the area of all of the exposed surfaces. Here are some formulas. The lateral area of a prism is represented by the formula L equals pH, where P is the perimeter of the base and H is the height. The surface area of a prism is represented by the formula S equals L plus 2B, or since L is the lateral area, you could say S equals pH plus 2B. Again, where P is the perimeter of the base, H is the height of the prism, and capital B is the area of the base. Let's do an example here. Find the lateral area and the surface area of this triangular prism. So what I'd like to do first of all is identify what the base is. Now you might think the base is on the bottom. In that case it would be this 12 millimeter by 8 millimeter rectangle, but that's not the base. Base doesn't mean bottom. Base, when you're talking about a prism, is one of two parallel congruent faces. And in this case, the base is a right triangle. It's this right triangle in the front here, and maybe I'll just go ahead and draw that. Ooh. That is 12 by 12, and this is labeled C. So there's a couple things I need to know about that. I need to know the perimeter of that, and I'll need to eventually find the area of that. So let's start by finding the perimeter. I don't know the length of the hypotenuse here, so I'll use the Pythagorean theorem. 12 squared plus 12 squared equals C squared. And working that all out, C is approximately equal to 16.97. So that means that the perimeter of this base is going to be 12 plus 12 plus 16.97, or approximately 40.97. Okay? Now the height of this prism is the distance between the bases, and the height is going to be represented by this 8 right here. The triangle in the front is 8 millimeters away from the triangle in the back. So to find the lateral area is perimeter times the height, or 40.97 times 8, or approximately 327.76 millimeters squared. Okay, so that's the area of all of the rectangular faces. So the rectangle on the bottom, the rectangle on the left, and the slanty rectangle that kind of looks like a hypotenuse. Now, to find the total surface area, what I need to add to the lateral area is the area of the bases. So to find the area of the base is going to be the area of this triangle right here. And for that I'm going to use the triangle formula. 1/2 little b times h. Now here's where it gets a little confusing. Big B stands for the area of the triangular base. This little b stands for the linear base of the right triangle. So big B is equal to 1/2. The base of that right triangle is 12. The height of that right triangle is 12, or the area of the base is 72. Now to find the total surface area, I'm going to do the lateral area, which is 327.76, plus 2 times the area of the base. Which gives me approximately 471.76 square millimeters. So the trickiest part, I think, of a prism is figuring out what the base is. What shape is the base? And remember, the base is not always going to be on the bottom. A cylinder is a solid that has circular bases connected by a curved surface. When I see a cylinder, I tend to think of a soup can. The bases are circles, top and bottom, and the lateral surface, if you were to unroll this, is going to be in the shape of a rectangle. If you've ever taken the label off of a soup can, you can see that the shape is a rectangle. So the formula for the lateral area of a cylinder is represented by L equals 2 pi RH, where R is the radius of the circular base and H is the height, the distance between the two circles. The total surface area of the cylinder is represented by S equals L, which is the lateral area, plus 2 times the base. But because the lateral area is 2 pi RH, and I know the area of the base is going to be the area of the circle, it's easier to use this formula here. S equals 2 pi RH, that's the lateral area, plus 2 pi r squared. Those are the areas of the two circles, the top and the bottom. So let's take a look at an example here. Find the lateral area and surface area of this cylinder. So we're given that the diameter is 15 millimeters. So that means that my radius is going to be 7.5, because the radius is half of the diameter, and my height is 18. So from here it's just very straightforward. Fill these into the formula. So the lateral area is 2 pi times r times h, and that's going to give me approximately 848.23 millimeters squared. So that's the area of the rectangular label on the soup can. My total surface area is going to take my lateral area, 848.23, plus 2 times the area of the circles. 2 times pi times my radius squared. And punching all of that into my calculator, that gives me approximately 1,201.66 millimeters squared. And here's our last example. I believe, yes, this is our last example. Find the diameter of the base of a cylinder if its surface area is 464 pi square centimeters and its height is 21 centimeters. So I know the total surface area, so I'm going to write the formula out here. S equals 2 pi RH plus 2 pi r squared. Okay, I know the surface area is 464 pi, and I know my height is 21. What I need to find is the diameter, but I think I'll start by finding the radius, and then I can double that to get the diameter. So let's plug in the numbers we know. Surface area is 464 pi, and that equals 2 pi. R I don't know. H is 21, plus 2 pi r squared. Let's clean that up a little bit. 464 pi equals 2 times 21, or 42 pi r plus 2 pi r squared. Now, remember what I'm trying to find is r, so r is kind of like my x. Notice that this is a quadratic equation because I have an r squared, an r, and a term with no r. So let's see if we can reduce the numbers a little bit here. I'm going to divide everything by 2 pi. Nice thing about that is all of my pi's are going to cancel out, and that's going to leave me with 232 equals 21r plus r squared. My pi's cancel out and my 2's cancel out, leaving me with r squared. My pi's cancel out, 42 over 2 is 21. My pi's cancel out, and 464 over 2 is 232. So this is a quadratic equation. Let's make it equal 0 and write it in more of a standard form. Okay, and so I have r squared plus 21r minus 232 equals 0. I'm going to use the quadratic formula in my calculator, and I get that r equals 8 and r equals negative 29. And of course the radius can't be a negative number, so it can't be negative 29. So if my radius is 8, my diameter is twice that, so my diameter is 16, and my units were centimeters. So in this section we looked at the lateral area and the total surface area of prisms and cylinders. Just make sure you don't have to have the formulas memorized, but make sure you're familiar with them and know how to plug things in.